In the beginning, dark. There was nothing we would recognize, no stars, no planets, no time as we know it. Then in an instant, everything that is, was, and ever will be burst into motion, a point of impossible heat and density. The birth of the cosmos, a blinding flash, creation made visible. From this singular event, the universe began to unfold. 5 of the scariest space facts of all time. Every particle, every force, every law of nature set the stage. From fire came form and fear. It was the start of an epic story, a story still being written across the fabric of space. The young universe was tempest, beautiful, dangerous, a boiling soup of particles and light, no mercy, no shelter. Slowly, order emerged. The threats did too. Gravity, the quietest of forces, can unmake a world. It can fling planets into starless exile. Number 5. Rogue planets, endless night. Fact 5. Rogue planets. Worlds torn free of their stars, set adrift. Not thousands, trillions may haunt the darkness. They wander the void between constellations. No sunrise, no seasons, only night forever. Surfaces plunge toward absolute zero. Air collapses, oceans freeze to black glass. Yet deep below, heat can linger. Radiogenic heat, tidal flexing, pressure oceans. Beneath kilometers of ice, a hidden sea could cradle chemistry, maybe even life. No starlight to betray them. Infrared ghosts, cold and faint. Our galaxy may be swarming with these dark worlds. Most will never meet a sun again, but some pass close to stellar systems, and their gravity whispers trouble. A close flyby could tilt orbits, trade energy, break harmony. Comets jarred loose, planets nudged askew. Tides rise, climates flip, skies change forever. Even without impact, a rogue can rewrite a system's architecture, including ours. The universe's most powerful explosions announce themselves as razor-thin beams. They are called gamma-ray bursts, brief, blinding lighthouses in the dark. Most are born when a massive star collapses and launches twin jets. Others spark from merging neutron stars. Focused like cosmic blowtorches, their energy outshines entire galaxies for seconds. The danger lies in their aim. If a jet were pointed at Earth from within a few thousand light years, its radiation could strip our ozone. Sunlight, suddenly unfiltered, would flood the surface with UV. Ecosystems would collapse. Food chains would break. Oceans would bleach. A mass extinction could follow. Some scientists suspect a past burst may have helped trigger one before. We see their afterglows across the cosmos. X-ray flashes, fading embers, expanding shock fronts. Long bursts mark dying giants. Short bursts betray compact collisions. Both carve space with lethal precision, and both remind us how fragile a living world can be. Fortunately, space is vast, and their aim is rare. We cannot predict the next. We can only watch the sky and learn from every burst we catch, cataloging their afterglows, mapping their origins, refining the risk. Gamma-ray bursts. Beautiful, terrible, and real. There is one more possibility. Quiet, invisible, and final. Physicists call it vacuum decay. The fabric of space may be metastable. If our vacuum is only a temporary state, a lower energy true vacuum could appear somewhere, like a tiny bubble. Inside that bubble, the laws of physics shift. The Higgs field, the forces, even chemistry. The bubble would expand at the speed of light, a smooth wave front rewriting reality as it goes. No warning, no signal outruns its edge. One instant, stars, the next, different rules. Not an explosion to see, just a horizon sweeping through. A new universe carved inside the old. Whether life persists there depends on new constants. Most likely, nothing like us survives. How likely is this? Measurements hint we may live near the border, metastable, not doomed. Even so, the timescales are vast. Tunneling could take longer than the death of all stars. And if it comes, we will never know it. After the wavefront, there is no time to tell the tale. This would be the quietest ending of all. No panic, no escape. Just a change of vacuum. For now, the risk appears low. The cosmos has endured 13.8 billion years. Nature accelerates particles to higher energies than we ever will. Colliders do not trigger this. If it comes unprovoked, by chance alone. Until then, we live under a calm sky, in a metastable sea. And we keep measuring because certainty hides at the edge of our equations. Possible, unknowable, not imminent. A whisper in the vacuum. One more ending among many. Fact 2. Black holes, where gravity becomes absolute. Cross the event horizon, and there is no coming back. A point of no return in space-time. At their hearts, space-time curves so steeply that even light cannot escape. Around them, hot accretion disks whirl, gas heated to millions of degrees. Come too close, and tidal forces pull harder on your feet than your head. Spaghettification. A star that strays near is torn into ribbons, its debris spiraling in a bright tidal flare. This stretching is tidal gravity, the gradient of pull across you, not just the pull itself. Near the horizon, time dilates. To a distant observer, your fall seems to slow and freeze. To you, the plunge feels swift. To the universe, your last light redshifts and fades. Gravity lenses the background, bending starlight into arcs and luminous rings. Most galaxies, including ours, harbor supermassive black holes at their centers. These giants weigh millions to billions of suns, feeding when gas and stars drift inward. Smaller stellar mass black holes are the remnants of collapsed massive stars. Some roam the dark between stars, revealed only by the subtle lensing of their gravity. Matter falling in can launch jets near light speed, guided by magnetic fields. Yet the horizon stays one way. Information enters but does not return. Orbits unravel, trajectories curve inward, escape becomes impossible. Cross the horizon, and all future paths lead toward the singularity. Inside, known physics breaks down, our best theories whisper, then fall silent. From outside, we witness only the afterglow, the last flashes, the fading arcs. And yet, black holes shape galaxies, regulate star birth, and stir structure on vast scales. They are engines and endings, sculptors of the heavens. Their tides, their lensing, their clocks that slow, all reveal space-time at work. By studying them, we learn where gravity meets the edges of knowledge. Spaghettification, time dilation, horizons, one phenomenon, many faces. Black holes turn fear into understanding and mystery into measurement. Between the islands of light lies a deeper mystery, the great silence. Billions of stars, billions of worlds, yet no clear signal. We sweep the sky with vast radio ears, waiting for an engineered whisper, and hear only the sigh of stars. This is the Fermi paradox. Where is everybody? We might be early, civilizations not yet kindled, dawn still gathering its first lights. We might be rare, life a fragile spark that seldom catches. Or there are great filters, gauntlets few survive, or a quiet cosmos, watching and unseen. Meanwhile, on the largest scales, emptiness rules. Vast voids stretch for hundreds of millions of light years, where almost nothing shines. Drift through one, and the darkness thickens. Galaxies thin to lonely embers. Any signal must cross oceans of vacuum, and aeons that drown meaning. Even a powerful beacon would fade, redshifted, scattered, lost to noise. So we listen, and wait, and wonder. Perhaps we are the first flicker in this region of space, the ones who must light the beacons, or perhaps others tried, and the night kept their stories. Either way, the silence teaches humility. We turn our instruments outward, patient, careful, refining the search. In the vast between, the great silence endures, a beautiful, chilling question. 5. Heat death. A universe cooling into darkness. 4. Big rip, space itself torn apart. 3. Big crunch, fire, collapse, rebirth. 2. Black hole. Era, giants feeding in the dark. 1. The dark era, almost nothing remains. Thin photons, neutrinos, a silence that deepens as time itself forgets. The universe will become a thin, uniform soup of scattered things, and even these survivors are not permanent. Quantum mechanics hints that matter itself may not endure forever. Black holes will rule that far horizon of time. They sweep up what drifts, growing ever more immense, yet even they are not eternal. Stephen Hawking showed that black holes slowly evaporate. A faint glow, Hawking radiation, leaks their mass away. For stellar black holes, this takes longer than the stelliferous era by a gulf beyond imagining. For supermassive hearts of galaxies, it could take a Google years. That is a 1 followed by 100 zeros. After the last black hole fades, the final chapter begins. The black hole era yields to the dark era, an almost perfect vacuum with only a thin mist of photons adrift, neutrinos, a few stubborn fundamental particles. All organized matter, gone to decay. All free energy, spent. A cold, dark emptiness, drifting toward maximum entropy. This is the ultimate silence, a final equilibrium, no work left to do. The story at last closes its book. And yet, we stand on a small planet circling a single average star. One among hundreds of billions, in a galaxy among countless others. Our lives, a flicker in 14 billion years. From this tiny shore, we cast our eyes to the vastness and dare to ask the oldest questions. How did it all begin? And how will it all end? That we can ask at all may be the most astonishing fact. We are the universe becoming aware of itself. Curiosity forged our science. We build vast telescopes to catch ancient light. We design delicate experiments to probe matter and energy. We map births and deaths of stars, of galaxies, of universes on paper and in code. Detectives of the cosmos, reading the past to foresee the far future. This story is not just observed, it is a mystery we strive to solve. With each discovery, the tale grows richer, deeper, more profound. Our final fate carries both grandeur and terror. Scales of time and space that dwarf our grasp. It can make us feel small, almost nothing at all. And yet, there is a strange beauty in that truth. A solemn peace in heat death's slow fade. A terrible majesty in a final fiery collapse. These endings are more than physics and cosmology. They frame our relationship with the universe. They define the widest context for our brief lives. For now, the stars still shine. Galaxies still drift in their slow, graceful dance. And here, we keep watch, learning, wondering. Tonight's light carries a memory of creation and the seeds of what may come. The final answer waits in the cold darkness between the stars. Which fact chills you most? Hold this brief, warm, sunlit instant. Now. In the quiet between stars, we wait.